TISON is a next-generation multi-scale modeling and simulations platform for cancer systems oncology. Let us explore TISON. Users can easily access TISON at tison.lons.edu.pk. From the home page, users can choose to log in through a registered account or guest logins. For the sake of the video, we will use guest login. Next, click the Project Explorer tab to open the Project Explorer page. On the Project Explorer page, users must click the Create a New Project tab. Define the name and the world size of the project in Create a New Project window. This will open up another page exhibiting tiles for networks, therapeutics, environments, cell circuits, cell lines, organoids, simulations, and analytics. We will begin our case study from the Networks editor. Click the Networks tile. To create a network, users must click Create Network button. Next, the users can choose to draw the network, write the rules, or upload an existing file. This is how a network appears on the canvas. Users must save the network before proceeding further. Once the network is saved, users may click Perform Network Analysis button to analyze the network. Here, we're using the default parameters to analyze the network. Users can also choose to upload the fixed node states file and the cell field classification file. Click the Run button to perform the deterministic analysis. Results are downloaded as a zipped file after the analysis is complete. The users can click the View Network and Analysis button to view the attractor landscape and cell field landscape of the results. These results are also downloadable. Users can also annotate their networks with patient-specific data towards designing combinatorial therapies using Therapeutics. Here, the users can create therapy by clicking the Create Therapy button and using the saved networks. Users can also import a new network along with its drug file. Define a name for the therapy and save it. Users can now perform the deterministic analysis on the saved therapy. Here we're using the default parameters for the analysis. Upload the fixed node states file and the cell field classification file for deterministically analyzing the network. Click Run to perform the analysis. Users may click Compare Therapeutic Steps button to compare the results of the therapeutic steps, that is, model, mutations, and genetic therapy. These results can be plotted in the form of bar charts or stack charts. These are the results for model, incorporated mutations, and therapy. Notice that the blue bar for division is present in mutations but absent in therapy. Users can also compare the steps of therapy by using the Compare Therapeutic Steps button in the Therapeutic Steps panel. Therapeutic Steps panel shows the steps of therapy, that is, the genetic mutations and genetic therapy in this case. The third editor of TISON allows the users to create cellular diffusive microenvironments. On clicking the Create Environment button, a model appears on the screen. The users can define the name of the environment, its physical time, and give the optional details. Next, the users must input the name, initial concentration, diffusion constant, time step increment, and boundary value for the layer. Click Create to design a new diffusive microenvironments layer. Click the Run button. The editor uses the partial differential equations to solve the complex environmental milieu. A 3D environmental layer appears like this on the canvas. TISON users can also employ the finite state machine to construct the cell decision circuits in the Cell Circuits editor. Click the Create Circuit button to begin the construction of the circuit. Integrate the elements from the Network, Therapeutics, and Environments editor. A process box is used to define the local and imported variables. The variables in this case study are defined using Gurley et al.'s minimal circuit model. Get environment, consume environment, decision box, mitosis, and cell death nodes are used to complete Gurley's circuit. Conditions for mitosis and cell death were defined in the decision box. Save the circuit and execute it within the Cell Circuits editor. Users can also choose to view the results. Assign the designed circuit to the cell line in the Cell Lines editor. Now construct an organoid in the Organoids editor using the Create a New Organoid button. Users can choose to draw cells in organoid with ranges, equations, and coordinates options. Here, we will draw the organoid with ranges, assign a cell line and choose a color, and set the minimum and maximum values for the x, y, and z coordinates. This is how an organoid appears on the 3D mesh. Name the organoid and save it. Users can also use Organoid Elements button to change the properties of the designed organoid. That's how we change the color of the organoid. Press Save for saving any changes. The color of the organoid has been updated on the mesh. The created organoid can then be simulated in the Simulations editor. Define a new simulation by inputting the name and the number of the time steps. Select an organoid from the list and click the Save button. A new simulation has been created. Double-click the simulation to start running it. A progress bar will display the time steps of simulation. Simulation is running. The simulated organoid can be seen on the canvas. The data obtained can be analyzed in the Analytics editor. Create a new analytical query. Define its name, select the simulation, and click Save. From the Queries List panel, we have plotted cell population total and organoid bounds queries. Thank you for watching. For more video tutorials, please visit the link of our YouTube channel given in the description of this video.